So hi guys, I forgot to give you this notes sheet. So just watch the video, and I filled in a lot of notes already to save time, and then I'm just going to print this for everybody. Okay, so the intermediate value theorem, so here it is. So this picture, let's come back to it in a moment. So here's the intermediate value theorem. It says if W is an intermediate value for f of A and f of B, okay, so that's one condition, and f is continuous on the interval A to B, then there must exist a value C, A less than C less than B, for which f of C equals W. Okay, so let's go back up here for a second. So right now, just like in class, I drew a picture so satisfying the first condition. W is an intermediate value for f of A and f of B. So here's W. It's an intermediate value between f of A and f of B. Then, if we satisfy the second condition of continuity and f is continuous on AB, okay, so if we, and I'll make it curvy, but it could be a straight line or whatever. I'll just make it curvy. And f is continuous on AB, then there must exist a value C, where A is less than C is less than B, for which f of C is W. So since f is continuous on this interval, I'll put an X there, we've got this point here that has a Y value of W, and so like the C that is guaranteed would be right there. Okay, and maybe I'll go like this, so right here, so we have f of C equals W at that point right there. Okay, now, using this theorem in an explanation goes something like this. Okay, so here's the explanation using the intermediate value theorem. You'll get that f of A equals some number, you'll get that f of B equals another number, and then you'll tell your reader that W, whatever it is an intermediate value. And W is an intermediate value for these numbers here. Since f is continuous on AB, by the intermediate value theorem, there exists a number C, A is less than C is less than B, for which f of C equals W. Okay, and notice here, guys, these inputs for f of A and f of B, those are always the endpoints of the interval that you're saying it's continuous on. These are always the endpoints of the interval that you want to say, you want to prove that C is between the values A and B, so that's why you have to do f of A and f of B. Okay, now let's go to the back. All right, I already drew this picture for the table, so let's read this. You are given that f is continuous on -3 to 8, and the table of values below. Okay, part A. For how many k values between -3 and 8, how many k values between -3 and 8 are guaranteed to have an f value of -6? Okay, so let's do this first. So I plotted the points from the table, okay? I drew a horizontal line at y equals -6. And now let me consider the continuity part. So f is continuous on -3 to 8. So that means that I can connect, what color should I use? I'll use this. Okay, so I can connect these. That's what continuity means. Okay. So we can connect those. And then look, guys, how many spots, how many points on the orange graph have a y value of -6? 2. Okay, 2 spots, 2 points. All right. So we've got a C value. We've got a C value like somewhere in here, like somewhere in there, we've got a C value that has an output of -6. And then over here, we've got somewhere around here another C value that has an output of negative 6. So the answer, how many, oh, k value, my bad, k values. How many, why k? What did I do? How many k values? Oh, duh, because the k is the input. Okay, as the input variable. How many k values between negative 3 and 8 are guaranteed to have an f value of negative 6? The answer is 2. So we're guaranteed to have 2 k values, but guys, this orange graph could be a lot curvier. So there could be more than 2 values, k values that have an output of negative 6, but we're guaranteed to have these 2 at least. Okay, now here comes the explanation part. Explain why there exists at least 2 values of c, where negative 3 is less than c is less than 8, for which f of c is negative 6, okay? Illustrate your explanation with a sketch. All right, we already did that. Now, here's the thing, guys. This is a little bit complex, so this will not be on your big quiz. Like, eventually, I could throw something like this on a big quiz, but not just yet. Okay, so here's the thing. So, explain why there exists at least 2 values of c between here for which that. Now, the problem is, if you go like this, if you do f of negative 3, okay, f of negative 3 is negative 5, and you do f of 8 is 1. So you have negative 5 and 1. There's negative 5, there's negative 1. If you are just considering these 2 outputs, the green line is not between them. Okay, the green line is not between them. So I have to split, I have to take this larger interval and I have to look at the smaller intervals inside of it so that I could prove to my reader what they're asking, because for f of negative 3 and f of 8, negative 6 is not an intermediate value. Okay, negative 6 is not an intermediate value for these endpoints of this larger interval. Okay, so I have to find some smaller intervals within this larger interval for which negative 6 is an intermediate value. Okay, so let's look. All right, well, I've got these 2 points from the table. So like this point and that point. All right, so negative 6 is an intermediate value for f of negative 3 and f of 0. Okay, so I can use that interval. Now over here, this point, or this negative 6 is again an intermediate value for these two values here. So I could say, so I could also use, what is that? That's 4. So f of 4 and f of 8. For f of 4 and f of 8, negative 6 is again an intermediate value. So I'm going to have to use these 2 smaller intervals within negative 3 to 8 to actually explain to my reader that we hit those, that we hit the output value negative 6. Okay, so we're going to take this, all right, and we're going to use, okay, for negative 3 to 0, all right, negative 3 to 0, we're going to use negative 3 less than, let's say C1 is less than 0, and because we're going to have 2 C's, and then we'll have, you know, this interval here, that's 4 to 8. 4 less than C2 less than 8. Okay, so we're going to use those, all right? So we're going to use the IVT on this interval, and we're going to use the IVT on this interval. Okay, and we're going to like put it together. All right, so for let's start with this interval. We've got f of negative 3 equals negative 5, comma, f of 0 equals negative 7, and negative 6 is an intermediate value, period. Okay, so we started the intermediate value theorem for this one. Now, instead of me finishing the explanation, let me move on to this part. Like, just I'll set this up that also. Okay, so then I'll be like f of 4 equals negative 10, comma, f of a equals 1, and negative 6 is again an intermediate value. Okay, now we want to tell our reader. So next we need to tell our reader that f is continuous on negative 3 to 0 and it's continuous on 4 to 8. Okay, so the first thing is you got to get the intermediate value, then you have to show continuity, and then you've got it. Okay, well, guys, they didn't tell us that f was continuous on either of these intervals. What they told us was that f is continuous on negative 3 to 8. And the thing is that these intervals are included in negative 3 to 8. So if f is continuous on this larger interval, it's got to be also continuous on the sub-intervals. So I'll be like this. I'll say since f is continuous on negative 3 to 8, it is also continuous on negative 3 to 0 and 4 to 8, period. Okay, so I showed continuity. I did the intermediate value stuff. Now I showed continuity. Now I can be like, therefore, by the IVT, and by the way, guys, if you don't say therefore by the IVT, they won't give you credit because you have to show them that you know the name of the theorem. That's what they want. Okay, so therefore by the IVT, there exists a C1, okay, and C1 is here, a C1, comma, negative 3 less than C1 less than 0, comma, and a C2, 4 is less than C2 is less than 8, for which f of C1 equals negative 6. And you could do two separate equations. You could be like f of C1 equals negative 6 and f of C2 equals negative 6, or you could just do one kind of run-on equation like that. That is legal. For which f of C1 equals negative 6 equals f of C2. All right, now, let's not stop there because let's look at what they're asking us to explain. Like, we've pretty much done it, but we just have to tie it. Like, we just have to kind of conclude it. They want us to explain why there exists at least two values of C. Negative 3 is less than C is less than 8, for which this. So we basically just have to state this at the end. Like, we've explained, but now let's conclude it. So we'll be like, therefore, there exists at least two values of C. You know, we just are going to repeat what they're asking us to explain. So therefore, there exist? I think there exist instead of exists. Therefore, there exist at least two values of C for which, two values of C, negative 3 less than C less than 8, for which f of C equals negative 6. Okay, guys, now again, on your big quiz, it's just going to be the more simple ones, like where you're just showing one value, explaining why one value happens. But, you know, in the future, we'll do more of this type of thing. Okay, so there it is. I'll talk to you soon. Bye-bye.